Let's look at an example program. In this example program, we're going to create a two-dimensional array of temperature values where the data in the array represents collecting one temperature value each day for a 2-week period. So the rows are representing weeks and the columns are representing the days. I'm going to paste this into IntelliJ so we can play around with it a little bit. All right. So let's look at the implementation of this program. So we're starting out and indicating how many weeks and how many days of the week we are interested in collecting temperature values. Again, we said we're going to collect temperatures for 7 days and 2 weeks. We have our temperature array declaration in here that's creating these temperature values. And this is using exactly that visual representation that we saw earlier, where we have the 7 individual columns in the table and the 2 rows, and we filled in the data just using the specified literal values when we initialize the array. If we wanted to print out all the temperature values in a single dimensional array, we learned that we needed to use a single loop, a count control loop that was either a for loop or a while loop. We could also use the enhanced for loop. Any of those would allow us to print out the individual temperature values in a single dimensional array. In this program, because we have 2 dimensions in our array, we're going to need 2 separate loops to be able to print out all the different values. That's because we have to iterate through all the different possible indices for the columns, and also iterate over all the indices for the rows in the table. I've done that here in our solution where I printed out a label saying the temperatures collected are. That will print out before we print anything about the array. And then I created a loop to iterate through each of the weeks, each of the rows in the table, and a separate loop to go through, and for each of those weeks, I will iterate through each of the columns in the table. The columns are numbered 0 through 6. And then each time I encounter a new coordinate, a new row column pair, I'm going to print out the value of the temperature at that weekday position. In other words, at that new index that I'm looking at. Let's think a little bit about what this will look like as we're executing this program. So initially, I'm going to set the value of week to be 0, and I'll check to see if it's less than 2. Yep, so I'm going to execute everything that's inside my for loop body. The first thing in there says I should execute this inside for loop. It says initialize the value of day to be 0 and check to see if that's less than 7. And of course, 0 is less than 7. So now it's going to print out the value at position week, which is 0, and day, which is 0. So it's printing the temperature value at position 0, 0 in our table. In other words, this very first data value in the top left corner. The next thing that happens in my program is I'm going to increment the value of day. I'm going to increase it by 1. So now day will be 1. And then I'm going to check to see if that's less than 7. It sure is. So I'm going to execute that inside loop body again and print out the temperature at position 0, 1. So it'll be in row 0, column 1. It'll print out the 55.6. Next, I'm going to increase the value of day. So it is 2. A 2 is still less than 7. So I'm going to execute the body of the loop. That'll print out the value of the temperature at position 0, 2. And in our picture, that's row 0, column 2. So it's going to print out the 76.2. And it's going to keep doing that, incrementing the value of day so that we're moving along in the first row of the table. Eventually, I'll get to the point where the value of the day is 6. And 6 is still less than 7. So I'm going to execute the body of the loop. That'll print out the value of temperature at position 0, 6. That'll print my value from the first row, row 0, column 6. So it'll print the 50.0. And then increase the value of day. So it's 7. 7's not less than 7. So I'm done executing my inside loop. My inside loop is the part that processes each column for each of the individual rows in the table. Once I'm done processing all of the columns, I'm going to print out a new line character so that I move to the next line in the output. And then after that, I'll go up to the top of my outside loop to increase the value of week. Right now, the value of week 0. So increasing it by 1 will make the week equal to 1. And 1 is less than 2. So I'm going to go through this whole process again. I'll restart the value of day at 0 because I'm restarting the loop at the beginning. So now the first data value that I print out will be at row 1, column 0. So row 1, column 0 is the 56.1. So let's run our program, and you can see that the values that are outputted are exactly like we've been talking about, that it prints out the rows and columns kind of just to matching the picture that we have of them in memory. We imagine that they look like rows and columns, and sure enough, when they print out in IntelliJ, they're also looking like those same rows and columns. One thing that's important to notice is that anytime we're printing a two-dimensional array, we always need a nested loop structure. In other words, the number of loops that you're going to need to print out your data values is going to end up matching the dimension of your array. So if we have a single dimensional array, we'll need 1 loop to print all of the data values. If we have a two-dimensional array, we'll need a nested 2-loop structure to print out all of the data values. Now, sometimes you want to do something with your two-dimensional table of data, and you might not need to process the entire table to answer a question. So for example, if we were looking at our two-dimensional table, one question we might ask is like, what's the average temperature value for week 0? We're only considering week 0. We only need that 1 row of the table. And so in order to answer this question, we'd have to just iterate across all of the columns while keeping the rows static. We also might ask a question like, what's the largest temperature value on a Monday? If we're only considering Mondays, we're only looking at 1 column of the table. The largest temperature value on Monday in our table would be the 60.3. And again, if we were writing a program to do that, we're not going to need a nested loop structure to just look at that 1 column of information. We just need a single loop structure to look at 1 column. We just need a single loop structure to look at 1 row. Or if we want to process all the data in the table, then we need a nested loop structure. Let's put that idea into practice. Look at these 2 example problem statements and think about whether we would need a single loop or a nested loop in order to solve the problem. Suppose we wanted to write an algorithm to find the smallest temperature value for a 2-week period. We need a nested loop or single loop. Remember, the key question to ask yourself is, would I need to look at the entire table of information in order to answer this question? Or do I need to just look at 1 specific row or 1 specific column? Also think about this question. Suppose we want to write an algorithm to find the largest temperature value on a Sunday. Would you need to write a nested loop or a single loop? Remember, think, do I need to look at all the data in the table or just 1 row or just 1 column? Pause the video for a few minutes and think about your answers. Then start the video again to check your responses. If we wanted to write an algorithm to find the smallest temperature value over a 2-week period, we would need to write a nested loop. That's because we have to look through the whole collection of information, all the rows and all the columns, to figure out which is the smallest temperature value. If we wanted to answer the question, what's the largest temperature value on a Sunday, that only involves looking at 1 column of the table, so we would not need a nested loop structure. We could write that with a single loop.